Alright, so I would like to share with you guys a little project I've been working on. You can get the source code at getlab.com/saspublic/class refactoring tools. If you go to the packages directory, you can download and install the latest package. So, this project is about making some class refactoring tools and some tools to make mock objects to use for unit testing. So I've got this LabVIEW project here, and it's kind of a contrived example, but let's say that we have a test step, and it has a test VI, right? So we got a project, we got a bunch of test steps, they have this test VI, right? They're all in different classes. And we want to test this VI, and we want to make sure, in this case, this test step uses an Agilent DMM, and it calls a couple of methods on this Agilent DMM class. It sets it to DC voltage, sets the range, sets auto 0, and then it reads it. And as part of our unit testing, we want to make sure that those are all these called in the correct order. Right, so we're going to use something called a mock object in order to do that. And so, let's take a closer look. Our test step itself, right, owns the Agilent DMM. And it's got a property node to read and write it to set the DMM, and here it's a DMM class. It's got some private data here. It's got a private VI. It's got some properties you can set, and it's got a bunch of methods here. And if we click on one, you'll see that it's calling directly to the Agilent driver, which is an instrument lib. Alright, so the first thing we want to do is we want to remove the dependency of this test step on the Agilent DMM. We want to introduce an interface class, and that will let us use test doubles and mock objects in our testing. So we're going to go to SAS, so tools SAS, class refactoring, and you get all this when you download the latest package. And when you go to create interface, you pick the starting class. We're going to start with the Agilent DMM. We're going to create an interface for it. And we're going to call that IDMM. So I for interface. So IDMM. Oops, I want those all caps. Okay. And we'll call this IDMM.LV_class. Perfect. And we're going to add it to our project. So we'll click OK. And we'll wait a second or two, and that'll pop up in our project. So now we have an IDMM class. The first thing I'm going to go do is go edit the icon, because the scripting tool is not smart enough to edit the icon yet. So I'll edit the icon. And if I look at this IDMM class, right, it's basically a virtual class, right? It has no data, no private data, and each of these methods are dynamic dispatch, and they're empty. And these are all the same methods that were dynamic dispatch in the original Agilent DMM class. So you can see it got rid of the property node, it got rid of the private VI, right? And so that's our IDMM class. If we go to the show class hierarchy, you'll see it inserted it, right? So our Agilent DMM class now inherits from our IDMM class. All is well, but our test step doesn't know anything about it yet, so we got to go in and change this. So we're going to right click here, go to replace, select a control IDMM, and now we've replaced it with that. And here we're going to change this. We're going to rename this property to say IDMM, and we're going to change this object to IDMM object. Now it's broken because we haven't propagated the changes, but we click Save All, it should go away, and everything should be good. And if we open up our test VI, you can see that this is switched to IDMM now. So now it relies on the IDMM, it doesn't know anything about the Agilent. Right? Obviously, whatever code calls this will still have to pass in the Agilent DMM. Alright, so now we've got our interface class, and now we're going to add a mock object. So go to class refactoring, create mock object. We're going to start with our IDMM class, and we're going to call this mock DMM. So new and we also want to add this to our project. Click OK, wait a few seconds, it should pop up. And now we have a mock DMM class. Again, I'm going to change the icon quickly just so that we can easily distinguish it. Now if I go to class hierarchy, right, it also inherits from IDMM. So we have our LabVIEW object, we have IDMM, we have our adjunct DMM class, and our mock DMM class. And you'll notice it has all the same methods as our IDMM, except that we added an initialize mock helper, which initializes this mock helper object, which gets stored in the class data. That's the only thing in the class data. And then we have a verify mock log, which verifies that all the calls were made in the correct order, and you pass in a desired call log. So you build this call log, and I'll show you how to do that in a minute, that says these are the calls I expected. When you run the verify, if those are the calls that it got, then it passes. If not, it gives you some message that tells you what didn't go right. And then if we look at any of these VIs, all they really do is they use the helper to log the call. And in the case of something like set manual range that has an input, all the inputs just get bundled into a cluster and passed in, and it will record the values of all the inputs. Alright, let's see, I think that's it for that. Now, how do we actually use this mock object in a test? So I've already created a unit test. Let me add it. So I've got this unit test VI, and I've got a 4-part test: setup, exercise, verify, and teardown. We're going to ignore all this here for a second. And so in the setup, what we're going to do is we're going to take our test step, which is the class, right, that holds the test VI, which is the VI that we're going to exercise, and we're going to pass it a DMM, but we're going to pass it the mock DMM. And before we pass it, we're going to initialize it. And then we're going to exercise by calling the code that we're going to test. And then we're going to take our mock object, we're going to branch it here, and we're going to run verify mock. That is going to verify that the calls were made in the correct order, and then that outputs a Boolean pass and then a message. And the reason we're able to branch this is because the only data that this mock object has is the mock object helper, which is a reference object, and so it doesn't care. And then here, we're building a call log that tells the mock object what calls we expected. There are some VIs under the SAS palette, mock object, generate call, and add calls to log. So you generate all the calls, you put them in an array, you add them to the call log, and then you pass that off to the mock object, and it will do the verify. And then there's a whole bunch of options for this generate call, but basic usage, you specify the name of the method, right? So the method was set DC volts, and that corresponds to the set DC volts here. Right? Leave off the VI, just set DC volts. And it has no parameters. This set manual range has a parameter. It's range. You bundle it up, you pass it in, and you give it the value that you expect. And then we call auto zero, and then we call take reading. So this is saying we got 4 calls in that order. Those are the 4 calls. And if those are the calls that were made, our mock should pass when we verify. So if I run this, you notice it passes. Now to make sure we don't get a false positive or something, we can go to this disabled case and we can enable this subdiagram so that now, right, we've told our mock object when we verified that these are the calls we expect, but we've got none. So when I run it, The test should now fail. And it gives me a message that says there were a wrong number of calls. It expected these 4 calls, and in actuality it got none. So that is basically it for mock objects. There are some other options here. You can set a numeric tolerance. You can set a tolerance for the range. You can pass an array of names of parameters that you want to ignore, that you don't care what the values are. And if you want, you can create your own custom parameters to do things like regex searches for strings, or case-insensitive string matching, or ranges for numbers, or different things like that. Handle different parameters. Alright, that is it for mock objects. That's pretty much everything you need to know. The tools again are under SAS mock object. And the basic sequence is you initialize the mock, pass it to the object you're testing, right? The exercise, you just call whatever method you want to test. And you build the call log using those the palette I just showed you. And at the very end, you verify the mock by passing in the call log that you want, and you get out a pass and a message. And you can use this in any unit testing framework you want, because it simply passes out a boolean and a message. So you could use the AST tester, the new one that just came out. You could use JKI-VI tester or whatever other testing software you like. So I hope you enjoy it and find it useful.